Okay, so this year when we're looking at trig ratios and trigonometric functions, we're going to start by looking at the trig ratios, but we're really going to try to focus more on the reciprocal ratios than what we did last year. Last year, and in grade 10, when you're first learning this, you all learned that sine is opposite over hypotenuse and adjacent over hypotenuse is cos, and opposite over adjacent is tan. Now, I also want you to recognize that if we're looking at this triangle, we can treat it as though we've got it on an axis, or we've got some point up here, and that point would be x, y. So that would mean that this is the x, this is the y, and we actually call the hypotenuse the r value. So with that being said, opposite over hypotenuse would be y over r, this would be x over r, and we'd have y over x for tan. Now, looking at the reciprocal functions, I want you to remember that cosecant is 1 over sine. Now, 1 over sine would be h over o, or r over y. Secant is 1 over cos, h over a, or r over x. And then finally, we have 1 over tan. Oh, that's bad, look at tan. Which is going to be a over o, or x over y. Now, when we talk about these ratios, we need to recognize that the signs don't actually change based on the reciprocal or the primary trig ratio. Now, what that is important for is when we start to look at the cast rule. The cast rule still applies that whichever primary trig ratio we have, the reciprocal is also going to follow the same properties. So we're going to have cast, which is cosine here. And that would have 1 over cosine would be the same sign, so that means that secant also goes there. Then we have all of them are positive there. Sine is positive there. And tangent is positive here. So with sine, we'd have cosecant, and with tangent, we'd have cotangent. And they're all going to work together. They're all going to be positive with their reciprocal function. All right, and that's important for a little bit later. So here, we've got special angle triangles. Now, right now, we're going to just start with our 1, 1, root 2 triangle. 1 squared plus 1 squared is 2. We need to have 1 squared plus 1 squared equals r squared. So it needs to be the square root of 2, and those are our 45s. Okay, now this year we're going to work primarily with radians, but you still need to remember how to use degrees. But those 45s are going to change. The triangle itself doesn't change, just changes the units that we're using. Okay, so we're going to go from degrees to radians, and we'll talk about that a little bit later in the unit. Now the second triangle is a little bit harder to recognize. You can remember that it's 60, 30, and 90, obviously, and then we're going to have 1, and then 2, and root 3. I'm fine with that. But I like to, when I'm doing this triangle, if I forget how to draw it, I draw an equilateral triangle, which would be 60, and I'm not going to draw the third 60 because I'm cutting it in half. 60, 60, and 60. Cut it in half, that makes 90 and 30. Okay, and then I make all of the sides 2. Again, this would be 1 and 1. And then 2 squared up here, minus 1 squared is 3. And that's going to make that root 3. So there's our triangle. We've got 1, 2, root 3. We've got 60 degrees and 30 degrees. And again, those degrees are going to change to radians, but we'll look at that a little bit later, and we'll probably redraw the entire triangle. All right, so determine the exact value for the other 2 primary trig ratios if sine theta equals 2 over 3, and we're between 90 and 180. So what that tells us right here, first, we're in this quadrant. Okay, so we're coming off there. And in that quadrant, both tan and cos are negative. Only sine is going to be positive. So that's going to help us out a little bit. The other things that we know. Well, we were given 2 over 3. Now that 2 over 3, remember, is the opposite over the radius. So we've got 2 and 3 there. So to find that x value, we're going to need to do a little bit of math. So we're going to do the Pythagorean Theorem. So we'll have x squared equals 3 squared minus 2 squared, which is 9 minus 4, so we have 5. So that's x squared, sorry. And then we get x equals the square root of 5. Okay, well, that's going to help us with our trig ratios because we know that cos theta would then be equal to, and we're in that second quadrant, it says between 90 and 180, so we know it's going to be negative. And cos theta is going to be root 5 over 3. Okay, so tan theta, again, is going to be negative, and it's going to be 2 over root 5. Okay, now a lot of people like to rationalize the denominator or get rid of the radical in the denominator. I don't really care right now if you do or not. You'd multiply both the top and the bottom of this fraction by root 5. So we would get negative 2 root 5 over 5. I don't care which one you have. It, again, doesn't really matter too much to me. So there are my exact values. No decimals, exact values. I found my root 5, I plugged it in, found my exact values. Let's try another one. So this one's important because it says it's between 0 and 360. Well, that means that we need to have 2 angles. So what I like to do when I'm doing these questions is first find out where we're going to be dealing with. So this is determine the value of x, and it doesn't say exact, so we can have a decimal, of sine x is 0.3215. So that means that sine is positive here and here. So I need to find my related acute angle, because both of these are going to have it. First, my related acute angle is going to go there, then it's going to go there. So my related acute angle is going to be the sine inverse of 0.3215. So 0.3215 sine inverse is equal to, and we'll just take it to the nearest degree, 19 degrees. Okay, if it's 19 degrees, that means that therefore x equals 19 degrees, or 180 minus 19. Which is 161 degrees. Now I'm going to let you do the second part of this question on your own. The one thing, when you're finding your related acute angle, and a lot of people struggle with this in grade 10, kind of grade 11 when you're dealing with it, you can always take the positive value and then just sub it in with your cast rule afterward. Okay, so again, I'm going to leave that with you. When you're finding your related acute, you should use positive 0.5. It'll help you find a positive related acute angle. Otherwise, some people struggle when they see that negative sign. Okay, determine the exact trig ratios for the 2 reciprocal ratios of secant theta equals negative 5 over 4, and we're between 180 and 270. Now there's a couple of ways you can do this. I personally like to switch it back to my primary trig ratios. So I would have, if I've got secant theta equals negative 5 over 4, well, that means I'm going to have 1 over, and we've got cos theta equals negative 5 over 4. Okay, and now I can switch everything around a little bit. So if I want to have cos theta, I would get negative 4 over 5. Now I'm in quadrant 3 because we're between we're between 180 and 270. So I'm down here. We know that cos theta is x and r, so we're going to need to find y. And it makes sense that that's a negative 4 because we're moving to the negative direction. Doesn't really matter when we're finding the y value. So we get y squared equals 5 squared minus 4 squared. And we get 25 minus 16 and 9. So those are all y squared. And that's going to tell me that y is equal to 3. So we've got a nice 3, 4, 5 triangle. Well, that's going to be tan theta is opposite over adjacent, or y over x. So we've got negative 3 over 4. So therefore, cotangent theta is going to be negative 4 over 3. And then sine theta is going to be negative 3 over 5. So, oh, tan should be positive, shouldn't it? Yeah, because they're both negatives. Excuse me. And let's change that. Because of the cast rule, again, not my fault, I didn't write it in. We've got 3 over 4, so that's 4 over 3. And then this one, we've got therefore cosecant is going to be negative 5 over 3. Okay, and now we've got the other two trig ratios. We found the r value, or sorry, excuse me, we found the y value to find our other two trig ratios. There are other ways to do it. I just find that that's an easier method because all you're doing is flipping your fraction at the end. All right, I'm going to let you punch these in yourself. I think the easiest way, again, is changing them to the primary trig ratios. So if I was doing this, the first one, I would have 1 over sine 42. Now, if you have an x to the negative 1 button or a 1 over x button on your calculator, it makes this a little bit easier. You can do 42 sine and get 0.6691. So that's 1 over 0.6691, I believe, and a bunch of decimals. Then I can hit my 1 over x button and get approximately 1.5. It says 4 decimal places, so why don't we do it to 4? So that's going to be 1.4945. Okay, and I would do something similar with both of the next values. Now, to determine the value of x here, we need to find where it's positive and negative. Again, I'll do the first one, and I'm going to leave the second one with you. So we've got secant. Now remember, secant is 1 over cos. So we've got 1 over cos x equals 1.567. So what that means is that cos x is equal to 1 divided by 1.567. Now we're in the whole 360 degrees, so we're going to have to find out where cos is positive, but why don't we find the related acute angle first? So we've got cos inverse of 1 over 1.567. And we get our related acute angle to be 50 degrees. Again, we'll take it to the nearest degree. Now, we're in the positive value here. So our positive value for cos is going to be here and here. So, therefore, what are we solving for here? X equals 50 degrees, or x equals 360 minus 50 degrees, because we're subtracting down, and we get 310 degrees. Okay, again, I'm going to let you do the next one on your own. I think it's good practice, and I don't think it's overly difficult, as long as you set it up in the exact same way. Because these are reciprocal functions, we can always relate them back to the primary trig functions and then do them the exact same way. So try that on your own. It shouldn't be too difficult, and we'll work on the questions in class.